Hello everyone, I am Dr. Sirajul Faisi. I welcome you in my YouTube channel. Today in this video, I am going to discuss about Hoff equation. Hoff equation. This equation is related to colligative properties. This is also very important topic in chemistry, especially in solution chapter of class 12. So let us start learning of Hoff equations today. So Hoff stated that there is a proportionality between osmotic pressure. What I am talking about? Osmotic pressure. Just remember, Hoff related to osmotic pressure and concentrations. Two parameters: osmotic pressure and concentration. Pressure and concentration, and absolute temperature. Not applied in concentrated solution. So you can see Hoff equations means pi directly proportional concentration, pi directly proportional to temperature. So if you remove the concentration directly proportionality sign, you have to introduce the one constant, and pi is equal to RCT. Here R is constant. So this suggests a relationship analogous to the equation to the ideal gas equation. You know, ideal gas equation also have 5 parameter, PV is equal to nRT. So osmotic pressure pi in a dilute solution or diluted solution was equal to the pressure exerted by the solute if it was a gas occupying the same volume. This is the Hoff equation statement. Now it will be more clear if you go through this formula, and formula is important for you. You can see pi V is equal to nRT, pi is equal to N by V RT, pi is equal to CRT, and pi is equal to MRT. These 4 formula is important for your calculations. You know what is the meaning of each term. I will discuss one by one. Here you can see pi osmotic pressure, T absolute temperature, N is equal to number of moles, V is the volume in liter, C is the molarity, N by V, and M is equal to molality, N by molecular weight. So pi is equal to CRT, this is the Hoff equation, and pi is equal to MRT, this is the Morse equations. Just remember, only you are changing from C to M. So if you are introducing M, that is the molality, and that is the Morse equation. If you have the C, that is the Hoff equations. Now I will give you an examples. What is the osmotic pressure of 1 gram sucrose, molecular weight 342, dissolved in 100 milliliter of water at 25 degrees Celsius, or it is given 0.082. So moles of sucrose is equal to weight divided by molecular weight is equal to 1. 342 is equal to 0.0029 divided by 100 ml. So 0.0029 moles in 100 ml multiplied by moles in the 1000 ml is equal to 0.029 moles. So how you calculate the molality? Molality is equal to moles. You know the total solutions 1000 ml. So pi is equal to CRT. You know the T value. You know the R value. You know the C value. So pi will come because this is the pressure. So ATM. ATM means atmospheric pressure. Now osmotic pressure of electrolytes. You know, my friends, they dissociate into ions. Increase number of particles ion form. So increase osmotic pressure. Increase osmotic pressure. Clear? Now sodium chloride ionizes into 2 ions. Each has the same effect on osmotic pressure as molecules. You know. So pi will be twice the solution contains the same molar concentration of non-ionized substances. Non-ionized means it is not. Now you can see the example. It will clear more. If you think about these molecules, K2SO4. Think what you are thinking about here. 2K plus and SO4 2 minus. How many ions? 3 times. FeCl3 4 times. Why? Because 3 ion of chlorine and 1 iron. So Fe3 plus 3Cl minus. Now pi V is equal to INRT or pi is equal to IMRT. So what does it mean? I is equal to dissociation factor. So for a strong electrolyte, I is equal to number of ions produced by ionization of a strong electrolyte in diluted solution. For weak electrolytes, I is equal to total number of particles, ion or molecules, divided by initial number before ionization. For non-electrolyte, I is equal to 1. Now, I will discuss lowering of vapor pressure lowering in my next video. So, if you like such type of video, then subscribe my channel, and thanks for watching.